Good morning, dear students. Last class I told different types of problems on 1 and onto function. At the same time, we discussed about bisective functions also. When the functions are bisective, about those also I told. When the functions are become bisective functions means here the functions f which is becomes both 1 and onto at the time only we are calling those types of functions are 1 function, bisective function. Now today we are going to discussing about invertible function or inverse of function. Inverse function here. What is meant by inverse function? When it becomes inverse function, when it forms inverse function, about that today we'll discuss. In this case also a function becomes both 1 and onto at the time only we can tell that f is inverse function or invertible function. Say a is one set here, a, and b is one set here, b here. A to b is mapping one function f is there. A set is 1, 2, 3, 2, 3, 4 is there. Here b set you can take a, b, c, d here. And 1 to a, and 2 to b, and 3 to c, and 4 to c mapping I have written. Inverse function means a to b it forms function, then f should be forms a function from b to a also. If you can move from b to a also, then f forms function, then we can get f is inverse function. But it will come in when it becomes f is also said to be invertible. When it becomes f is also becomes inverse function if you can move from b to a. Say here diagrammatically I am showing here a to b one function is there. 1 to a, and 2 to b, and 3 to c, and 4 to d. That is the image of 1 is a, image of 2 is b, image of g is c, and image of 4 is the d. If you can move from b to a also, if you can move from b to a, so let us we consider g function. Then image of a 1, image of b 3, image of c 3, image of d 4. Like that if you can move like that also, then it forms function. Then we are saying g maps from b to a is said to be a invertible function or inverse function. See, if you can observe this, f is both 1 and onto, because the different elements of domain a are associated with different elements of codomain b. Similarly, in the same way, if you can move from b to a, b to a also becomes function. B to a also becomes function means here it becomes both 1 and onto. 1 means different elements of domain A are associated with the different elements of codomain B, then f is said to be onto. 1. Onto function is codomain is equal to range. Here codomain is ABCD, range is ABCD. That's what f is said to be onto also. If f is said to be both 1 and onto, then only we can say that f is invertible and inverse function exists. If it is not 1, it becomes only onto. At a time we can't define inverse function. If it is not an onto, it becomes only 1. At the time also we can't define inverse function, and we can't tell about that inverse does not exist. See, diagrammatically I am showing here f is both 1 and onto. F is both 1 and onto. Thus f is said to be invertible. or inverse function exists, or we can write inverse function exists. Inverse function is exists. Exists like this. See, some diagrammatical I am showing which is not inverse and which is not which is inverse. I will show you some more examples. Examples for this is, it is A here and it is B here. A to B is 1, 2, 3, 4. A, B, C, D, E, F, G here. 1 to A, 2 to B, 3 to C, and 4 to D. F is 1, 1. But it is not an onto, because A to B is one function, and from B to A, let us be considered G does not forms a function here. So from this we can write different elements of domain capital A are associated with different elements of codomain B. Therefore, F forms a 1, 1 function. Therefore, F is 1, 1 function. F is 1, 1 function. F is 1, 1 function, or F is a bisective function. If we can move from B to A, see here, codomain is not equal range. Codomain is total whole set A, B, C, D, E, F, G. But range is only A, B, C, D. But we can't equate them. We can't equate them means F is not forms an onto function. That's what we can tell. F is not onto function. When it is not becomes onto function means, if we can move from B to A, only 4 elements A, B, C, D associated with all the elements of set A. But remaining elements E, F, G, they are not having association with any element of domain capital A. That's what easily we can tell inverse function does not exist. If you want to make B to A function, and E, F, G must be also associate with any elements of domain capital A. But those 3 elements do not have any pre-images in the domain capital A. That's what F is not an onto function. F is not an onto function. F is not an onto function. Therefore, inverse function does not exist for F. Inverse function does not exist. Inverse function does not exist here. Inverse function here does not exist. If you can move from B to A, it does not forms a function. That's why wherever if you can see that in functions about inverse function or invertible function, that F must and should forms both 1, 1 and onto. Then only we can say F is 1, 1 function. Otherwise, F is not. So before this one example I told, in that example, F forms both 1, 1 and onto. If F forms both 1, 1 and onto means, if you can move reversely, that is conversely, from B to A also becomes function. At the time we can tell F is said to be invertible, or F is inverse function, or inverse function exists for the function F. See, I will show one more third example also here. Example 2 here. It is the example 1 here. Example 2 here. It is A. It is the B. One, 2, 3, 4 here. A, B, C, D like this. See here, like this we can it is also inverse function. Mapping should be in any way. But in the case of 1, 1 or injective function, the different elements of domain capital A are associated with different elements of codomain capital B. That is a distinct element. Distinct or different, both are giving same meaning here. In some textbooks, distinct will be there. The distinct elements of domain capital A are associated with the distinct elements of codomain capital B. At the time we can tell f is said to be 1 function. To check onto means codomain is equal to range, whether is it satisfied or not for the given diagram. Now in case of onto, we are going to checking codomain is equal to range. In that second example, the codomain is ABCD and range is ABCD, and these two are equal or not. We got equality of function f no here. That's what we can tell, f is both 1 function and an onto function. When f forms these two means we can tell f is said to be invertible or inverse function exists for the function f. That's what here B2 also becomes function. B2 also it becomes function. Let us be considered G here. That's what we can tell, f is both 1 and onto. F is both 1 and onto. Thus, f is said to be invertible. F is said to be invertible. Or inverse function is exists, we can write. On that we are going to giving some different types of problems. And that from the exercise 1.3 we are going to solving different types of problems on invertible functions. Let the defined one function. Now we have to check whether it is invertible or not. At the same time we should write the inverse function also. See here. First question. Let f maps from R to R. Let f maps from R to R, real number to real number. A is given by f of x equal to 4x plus 3. F of x equal to 4x plus 3. Then show that f is invertible. F is invertible. And also find inverse function. And also find inverse function. And also find inverse function here. First we have to show f is invertible or not. F shows invertible or f becomes onto means f becomes inverse function means before that whether f is forms 1 or onto. That is f must be forms 1 function and f should be forms onto function. If f becomes these two, then only we can tell f is said to be invertible and for this inverse function exists. Let us now we are going discussing about 1 function. Solution for this question is solution. Let the given function f of x equal to 4x plus 3. F of x equal to 4x plus 3 is defined on f maps from R to R. First one is 1 function. 1 function. Already I told on formula also to form a 1 function. 1 function is we considered f of x1 is equal to f of x2 on by solving that finally we should get x1 is equal to x2. If we can get that procedure easily we can tell f is said to be 1 function. That is f of x1 is equal to f of x2. F of x1 is 4x1 plus 3 is equal to 4x2 plus 3. 3 gets cancel. 4x1 is equal to 4x2. Now 4 gets cancel. That is the x1 is equal to x2. Therefore f is a 1 function. F of x1 is equal to f of x2, that is 4x1 plus 3 is equal to 4x2 plus 3, and 3 gets cancel. Then we will get 4x1 is equal to 4x2. On gets cancellations, x1 is equal to x2. Therefore f is said to be 1 function. Now next onto function. Onto function. Let us will discuss about onto function for this function. Onto function. Onto function formula is f of x equal to y. F of x equal to y here. F of x means here already I told now f of x equal to 4x plus 3. 4x plus 3 is defined on f maps from R to R. This formula should get here. F maps from R to R here. See here, f maps from R to R means f of x is 4x plus 3 is equal to y. And 4x is equal to what we can write? Y minus 3. X is equal to what we can write? Y minus 3 by 4. Further you have to check. You consider equation number 1 this. For all y belongs to capital R. For all y belongs to capital R, then we will get x is equal to also one real number. Because R to R defined. For all x belongs to capital R. Or for all y belongs to capital R. Y belongs to capital R, then x is equal to y minus 3 by 4 is always real number. Is always a real number. Therefore, f is said to be onto. F is said to be onto function. An onto function. R to R means any real number should get a real number. Any real number should get a one real number. Like that if we can get means that is f is an onto function. You can take any real number y place, then x also becomes real number. For example, 4 you can take, y is equal to 4. 4 minus 3. 1 by 4, x is equal to 1 by 4. X is equal to 1 by 4 means, is it real number or not? That's why it is always real number. Similarly, same we can take 3 also. 3 minus 3, 0. 0 by 4. 0 by 4, 0. X is equal to 0. X is equal to 0 also real number. Like that, you can take any real number in place of y and again you will get a real number x. Real number for x also here. Next is therefore f is said to be both here you should write After completion of onto function, already I told any function forms an onto function means for that we have to give verification. How means I'll show now verification. See here, consider f of x equal to 4x plus 3. In this case put x equal to y minus 3 by 4, that is f of x equal to 4 into y minus 3 by 4 plus 3, and now 4 gets cancelled here. F of x equal to y minus 3 plus 3, minus 3 plus 3 gets cancelled, therefore f of x equal to y. And finally we can write f is forms both 1 1 and onto, therefore f is both 1 1 and onto functions. F is both 1 1 and onto functions. Not only for this, a function f forms an onto function means for that we have to give verification like that. If it is not an onto function, up to that we can stop, no problem. Therefore f is not an onto function, I can stop it up to that. If f forms onto at a time only, we must and should give verification for that function, that is we must and should prove for f of x equal to y. How we are getting a proof of f of x equal to y means, we got from equation 1 x value is y minus 3 by whole divided by 4. Now we must and put x value in the given problem. On putting that, finally we should get f of x is equal to y. That is the verification for onto function. Must and should. 1 mark should be allotted to that verification here. That's it. Not only for this, in any function, in any onto function, in any problem, then f forms both 1 1 and onto at a time only. Both on 1 and onto at a time only, we must give verification for that function. Verification must and should here. Next, last one is both 1 1 and onto function. Here we got this now, that is x is equal to y minus 3 dividing by 4. Equation number 1 this is. After completion of that, f is both 1 1 and onto, therefore f is said to be invertible. F is said to be invertible. Thus inverse function exists. Inverse function exists. Last one is inverse function, right? Inverse function. Inverse function formula is same. What is the onto function formula? Same formula we are going to writing for inverse function also. That is inverse function formula is f of x equal to y. X is equal to, if you can send f that side, it becomes f inverse of y. For x in place of x from equation 1, we must and should collected this number, that is the y minus 3 by 4 is equal to f inverse of y. Or we can write f inverse of y is equal to y minus 3 by 4. But the problem is there in terms of x. In terms of x means we must give answer in terms of x only. But we got f inverse of y is equal to y minus 3 whole dividing by 4. Then f inverse of x is equal to x minus 3 by 4. Like that here, how to give proof for 1 function, onto function, and afterwards verification, and finally should give that inverse function also. Not only for this, in any problem, show that f is invertible or find inverse of function. Like that, if they can ask means, first we must give proof for 1 function, next we must prove for onto function. Whether it is onto function, then we must and should give verification, that is f of x is equal to y, and finally we must write inverse function also. Inverse function formula is f of x is equal to y. These 4 if we can do, then only that is a procedure for inverse function. So you have to check f is 1 or onto or not, f is onto or not. If f is not an onto function means at that time only we can write f is not an onto function, therefore inverse function does not exist. At that we can write. If it is an onto, if it is in both 1 and onto, at that time we must and should give verification. At the same time finally should write inverse function also. Like that today I told information about inverse function. At the same time I have given and I did one question also. Next tomorrow we will solve some more different types of problems on inverse functions. Thank you very much.